So now let's see what is rational horizon, sensible horizon, and what is visible horizon. So this is Earth, and this is the celestial sphere and celestial poles, geographical poles of the, and celestial. So basics we have already seen, and now we are going to see what is rational horizon, sensible horizon, and visible horizon. So first we have the observer. We have the observer. This observer is in this part of the earth, and let's first understand what is zenith. To understand rational horizon, we should know what is zenith and nadir. So zenith is the basically the point directly above the observer on the celestial sphere. So if you want to define zenith, it is the point right above the observer on the celestial sphere. So this is the definition of zenith. Now let us see what is nadir. Nadir is exactly opposite of nadir. Nadir is exactly opposite of zenith. So if you want to define nadir, nadir is the point on the celestial sphere which is directly opposite to the observer's zenith. So it will keep changing with every observer. Now let us understand what is rational horizon. So rational horizon is basically if you slice the celestial sphere into two parts passing through the center of the earth, and which divides the zenith and nadir into 90 degrees away from them, that is equal parts. So so the great circle passing through the center of the celestial sphere, which is equidistant from the zenith and nadir, or 90 degrees from zenith and nadir, is called the rational horizon. So rational horizon is a great circle passing through the center of the earth on the celestial sphere, and which is midway between the observer's zenith and nadir. And depending on the observer's position, zenith and nadir will change, and that's why also the rational horizon will always keep changing. Now we can see the observer is moving, so zenith, nadir, and rational horizon are changing. So we have clear understanding of what is rational horizon. Now we will understand what is another horizon, that is sensible horizon. Now zenith, we have taken a cut this rational horizon. We have taken the top portion of the slide. So this is what we can see. This is the rational horizon. This is the celestial sphere. This is the zenith, and this is the earth. And we have the observer here. Now, now let's see the sensible horizon. So this is the sensible horizon. As you can see, it is passing through the observer's eye because observer is standing in the bridge wing, let's say, and the let's define what is sensible horizon. So the sensible horizon is nothing but it is a plane or the circle passing through the observer's eye level and parallel to the rational horizon. So this is sensible horizon. Now we will see what is visible horizon. So let's bring the visible horizon. So from the eye up to the maximum extent of the earth with the curvature which we can see, that is your visible horizon. Visible means we can see, and the horizon up to maximum where we can see. So you can also call it a actual horizon or the present horizon, which will depend on the visibility and all. And this is called visible horizon. So if you want to define visible horizon, the curvature of the earth, as we can see, the curvature of the earth which limits the field of vision of an observer is is called visible horizon. So the limiting edge of the area is called the visible horizon, that is maximum what a observer can see. So now let's see what happens with the rational. So let's see correction of altitudes. So when we take a side, for example, latitude by meridian altitude, we take the sextant altitude and we apply some corrections to obtain the true altitude. So the journey of getting true altitude from the sextant altitude, let's see. So before understanding the corrections, first we will understand some basics about the horizons. We have already done rational, visible, and sensible horizon. So this is celestial sphere, geographical poles, and so we have an observer. Exactly above the observer is zenith, and opposite to zenith is nadir. And the rational horizon is 90 degrees or midway between this zenith and nadir. So, so rational horizon keeps on changing, and the observer zenith nadir all keeps changing. Now we know. So sensible horizon is from the eye, you know, and and sensible horizon is always passing through the observer's eye, and it is not passing through the center of the earth. So it is not a great circle, but it is a small circle. So rational horizon is a great circle, and sensible horizon is a small circle. So visible horizon is nothing but maximum a observer can see. So what is the main thing while taking a sight? We need a celestial body. So this is sun on the celestial sphere, and our main thing is to take the sextant altitude of this sun or celestial body. So when we measure the altitude, we we apply corrections to get the observed altitude. So basically, either we take the upper limb of the sun or upper edge of the sun, or we take the lower limb of the sun, that is lower edge, when we are measuring the sextant altitude. Mostly we use lower limb because it is easy to lower the lower limb of this. So we are measuring the angle from the visible horizon to the lower limb of the sun. Basically, we are getting this angle from the sextant horizon. But when we obtain this angle from the sextant has its error called the index error. If it is on the arc, we have to subtract, and if it is off the arc, we have to add. So after applying the index error on the sextant, what we will get is this angle, that is the observed altitudes of celestial body from the visible horizon to the celestial body. So this is not the sextant altitude but the observed altitude after applying the index error. Now as we know that when we apply, we next correction is called the dip correction. So we'll get the apparent altitude. So dip correction is for the height of eye and depends on the height of eye. So we are at a height from the sea level. So to counter for that height of eye from the sea level, dip correction will eliminate the height of eye. Basically to get the altitude at the sensible horizon. So dip is the correction between your visible horizon here and your sensible horizon. And always to obtain uh, apparent altitude, we subtract the dip correction, apparent altitude. Once we apply for the dip correction, the altitude left is your apparent altitude. So apparent altitude is between the sensible horizon and the line joining through the body. And dip correction we get from nautical almanac, we will see. Now that is the important correction which is called the total correction, which is for lower limb or upper limb of the sun, right? We will see. So what is total correction? So the first correction which is included in the total correction is the refraction. What is refraction? Is deviation of light rays passing from one medium to another. So light rays are passing from sun to different mediums while traveling to the observer or earth, and where earth surface is very denser near the earth, and as we go higher and higher density decreases. So different densities of air deflects the rays in different directions, and because of that what we see is not exactly. So this is the earth and x is the body like the sun, and the light are coming fine and getting reflected here, and once they are entering to the observer we see it like this, and we assume that the sun is right there at x dash, but actually the sun is at x. This is an error because of reflection. So this reflection error is included in the total correction. Now let us see what is another correction which is called the correction for the semi diameter. So for semi diameter, as we already saw, when we obtain the sextant altitude, we either take the upper limb of the sun or we take the lower limb of the sun. But what is our main intention is to take the angle which is at the exactly at the center of the body, because we need the altitude for the center of the body. So we apply the uh, correction for the semi diameter, that is half of the diameter, that is the radius of the sun. So generally so if I take lower limb, this much altitude from this red to blue we have to, it is missing, so we have to add this much amount of altitude as a type of correction which is called. So when we are taking lower limb we will add, and if I have taken upper limb, to bring it down this much part we have to subtract. So if we are taking upper limb we have to subtract the semi diameter correction, and if we are taking lower limb we have to add. So it is also included in the semi diameter correction. And there is a third correction which is parallax. So let's see what is parallax. Now we can see that the celestial body, it take the angle from the visible horizon, and then we subtract dip, we got the apparent altitude. So our main aim is to get the true altitude between the sensible horizon and the center of the body. But true altitude is from the rational horizon. So we don't want the uh, angle, we want the angle which is passing from the center of the earth. That is the true altitude of the celestial body. So we are at apparent altitude and we want the true altitude from the center of the earth at the rational horizon. So from the body we will join two lines, with one which is passing to the observer and one which is passing through the center of the earth. Now this angle which is made from the body, which is called parallax in altitude. Now this triangle of sensible horizon and the lines passing through the observers from celestial body and to the center of the earth. So let us say the angle at the body is A and the angle between sensible horizon is angle B. Now if you are aware that sensible horizon parallel to rational horizon, now in any triangle, if this is A and this is B, it's interior angles. So the exterior angle is the sum of interior angles. So basically C is equals to A plus B. So if C is A plus B and sensible horizon and rational horizon parallel, then this angle will also be C. And we know that angle C is equals to A plus B. So that means, so to obtain true altitude, we need A plus B, that is obtaining C and then again this altitude. Very simple. So this angle is sum of this, and this is the reason why we apply a parallax correction. And by applying parallax correction, we obtain the angle on the rational horizon. That is the reason why we apply parallax correction. To obtain the altitude, observer's rational horizon parallax correction is applied. To obtain true altitude, we apply semi-diameter parallax correction and the refraction. All these three are included in the total correction, and they are given in the nautical almanac. So we are now, after applying this correction, we get the true altitude. That is nothing but this angle at the center of the earth between the rational horizon and the celestial body. Now we have the clear idea of all the correction.